In this video, we look at the compounding of interest problem as a growth of money problem, and we're going to see the relationship of compounding of interest to exponential functions again, and we will tie in the Google Sheet technology also to help us with these problems. So for example, just recall that we know the compounding of interest formula is the amount of money in an account at any time where you've invested an initial amount of dollars, and we know that there's a compounding value in, and there is an interest rate R, and then we'll raise all of that to the t power. This is the compounding of interest formula written as A0 times a number to the t power, where we can see that the number b for the base of the exponent is the formula 1 plus r over n to the nth power. Okay, so by way of example, we might be able to take an r and an n value and an additional amount of money problem and turn that into an exponential function. So if we say, for example, that our interest rate is 20%, just for a mathematical number to give, not a realistic interest rate, but an interest rate that we convert it to a decimal. And let's say that the number of compoundings is 4. This would be called quarterly compounding. And so then we can use this r and this n value to compute 0.2 divided by 4, which is 0.05, otherwise known as 5% interest. And this is the 5% interest that's given. This is the 5% interest that's given every 3 months, or 4 times a year. Okay, let's assume that we've started with maybe $100 in the account, and then it's possible to write down the formula for the compound of interest problem, how much money you have in the account at any amount of time t, where t is going to be measured in years. So we'll have our $100 times 1 plus the 0.05. And we need to raise that to the nth power, which is 4, right? And then all of that to the t power. So what we need to do is 100 multiplied by 1.05 to the 4th power to the t power, and our number b is 1.05 to the 4th, which we will compute in our spreadsheet problem or in our calculator. I will do that over here on the left. I'll just ask really quickly for 1.05 to the 4th power, and we can see that that comes out to be 1.2155, let's say. So 1.2155. So here is an exponential function. Okay, it's of the form a constant, in this case 100, and our base is the number 1.2155 to the tth power. Okay, so if we wanted to, for example, put this formula into Google Sheets, for example, and to figure out how much money we have after any amount of time, like 1 year, 2 years, or 2.5 years, or 3 years, you can see, we can put certain numbers in there. We need to put in our formula, which is going to be 100 multiplied by 1.2155 to the t power, and t is in the a column, A5. Okay, and we can see that the $100 is what we had to start with, so the amount of money evaluated at time 0 is equal to the 100. That makes sense, because if you put in 0 for t, 1.2155 to the 0th power, you'll get 100 multiplied by some number to the 0 is always 1. 100 times 1 is 100. So that's why we are seeing this number here, what it is. If you take that and drag the formula down, you will see that how the $100 grows via compounding of interest over the next 3 years. So after 3 years, you have $179.58 in your account. Okay, it's interesting to note that one could, since we know that there is that this data right over here. Okay, I need to put a big exclamation mark on this, that this data that we have over here in Excel, or sorry, in Google Sheets, the data that's coming from this column right here, the amount A data, since it comes from an exponential function, it came from this formula. We know that this data is coming from an exponential function. So watch what happens if I were to ask the computer to find an exponential function that fits this data. Okay, we could insert a chart. And just like we did with linear regression, we could ask the computer to do a trend line. And the data is no longer linear, but it comes from an exponential function. So we could ask for the exponential function and show the equation that comes from. Okay. Now let's take a look at the meaning of this formula. Okay. Let's see if we can make it match up with what we have just done a second ago. Okay. We showed, whoops, sorry y'all. We showed that the exponential function for this data came from this formula right here. Okay. Google Sheets is saying that that formula is 100e to the 0.195 to the t power. Okay, so let's see if we can understand the relationship that Google is telling us. So from Google, okay, we took the data. We had data from our exponential function a, right? And we asked for an exponential fit of that data. And the answer that we got was that a of t is equal to 100 times e to the 0.195 multiplied by t. Okay? But you'll remember from our exponent rules that it is possible to write this e to the 0.195t. It is possible to write that instead as e to the 0.195 to the t power. Okay. And if you focus on that pink number for a second, the pink number is going to be from our compound of interest discussions. This is going to be, the pink number is the amount of money that $1 grows to at an interest rate of 19.5% in 1 year, compounded continuously. So if you ask the computer to tell you the value of e, the exponential of 0.195, can you see the answer that you get? The number in pink comes out to be 1.215, which is the number that we had from before. So the formula that Google is giving us is the same, just written in a slightly different format, 1.215 to the teeth power. So Google and the formula that we were writing down from our compounding of interest are the same. Okay? And we want to get into some more details of this process a bit later. What happens? How do we know that our data that was given is actually coming from actually an exponential function? Okay, and I think we can see here that our data that we got over here in blue came from this formula that we knew was an exponential function already. When we ask the computer in Google to fit that data, we get this formula in black. But doing our exponent rules, we can see that this formula that we got from Google is equivalent to the formula that we started with. So that's a nice thing to see, that the answers are being consistent with each other. Okay, in the next video, we'll dig deeper into this idea and how do we know that data we're given is actually from an exponential function.